any other kids, and in 1998, he started the Western Colorado Math and Science Center 20 years ago now. It's hard to believe. At Wingate Elementary School, and after a year, he moved from the classroom there to a much bigger facility where the Science Center was for the last 18 years before he moved to the beautiful facility that's at now at the campus. I think it's just marvelous the work that John has done to put science in the hands of kids, and I'm so happy to see Jen, all the other employees, and the board grow this center to such a wonderful facility and see such great exhibits there. John asked me, he said, you know, whenever I run into people, they're always asking me, what you're up to now? So I thought I'd just cover that real quick so that John doesn't have to tell you guys for me each time he runs into everybody. So after I graduated high school, I went to CU Boulder. I got an undergraduate degree at BS in Electrical and Computer Engineering, and then started work at Lockheed Martin Space Systems Company. And while I was there, I went to DU and earned a master's degree in mechatronic systems engineering, and then got married to my wonderful wife, Marissa. We have 2 children, Talon, who's 4 years old, and Finley, who's 1 year old. And then after 5 years at Lockheed Martin, I started my own company called Galvanic Engineering. So there you go, that's what I've been up to since I moved away. So I'll talk just a second about my company, Galvanic Engineering. I started in 2011. I have, it's a small company. I just have 2 full-time guys and a part-time guy that works for me. And most of our work is for Lockheed Martin. We have contracts to support test systems for spacecraft, as well as test or various systems for the F-35 fighter program. So lots of interesting work with Lockheed, but we also do work for very small companies, startups, up to very large corporations. For instance, last summer we got to build a high-power system for a high-altitude airship. So it's exactly what I was hoping to do when I grew up. I get to do hands-on engineering every day. I love the work that I do. My hobby is my work, and my work is my hobby. And it's exactly what I was hoping to do. And so glad that John was able to accelerate my pathway as a young child so that I can do this. In 2014, we started building a home, and guess who was there on site to help me out? It's funny how some mentoring relationships just continue on, and John helped me run 13,000 feet of low voltage cable through this house. And all hands were on deck. My dad was always coming to help. Even my toddler had to learn how to run a forklift to get the project done. But, sorry, as a proud parent, I have to sneak a picture in there. In 2014, rewinding just a few months, we're about to break ground on building this new home. I was going to be the general contractor. It's something I've always wanted to do. I watched my dad build our home while I was growing up. And so I got things in order to do that. I offloaded some work that I was doing onto some other people. I set things up so I'd be working part-time. We had a baby on the way. Our first was being born in a few weeks. So everything seemed like it was working out well. And then Google Ventures called me and said, there's a company in California that's building this amazing drone system, and they need engineers. Is this something you'd be interested in? And I thought, well, I'll talk to them. So I called them back, and they convinced me to fly out there the next day. So I flew out there, and I met this, I call him a young kid just because he's younger than me. This guy named Colorado, he picks me up at the airport and drives me to their facility where I meet the team, which is these guys. And there are these top-notch engineers. They were interviewing me, but from that I could quickly see these are some of the smartest guys I've met in my life. and I'd like to work with them. And they said, what we want you to do is design all the electronics for this cutting edge drone that's going to save lives all over the world. I'm like, that sounds great, but I just plan to not be taking on more work. But they were very convincing, so I hopped on board, and it has been quite a journey. So, so I asked, how are we going to save lives with this drone? Everybody's building drones today for this reason or that reason, but you don't really see many of them doing very significant things. And they described to me, there's rural areas all over the country, here in the US, but also the world. There's a lot of places where there's just not fast access to medicine and other blood and other health-saving supplies. And they quickly told me the story about Rwanda. So the CEO who I just mentioned, Keller, he had been in Rwanda. He was a very well-known rock climber. So he had been all over the world. And during his rock climbing, he realized, there's places that just are really hard to get to. So this picture is from Rwanda, where this is, from my understanding, a typical road in Rwanda. It's hard to get from point A to point B. The roads are dirt, it rains there all the time, and it's just really hard to get around. So I asked them, what kind of drone are we building? And they described a fixed-wing aircraft. And that's when I started to get excited, because everybody's building these quadcopters that they can't carry much payload and they can't go very far. So I thought, this thing could actually maybe do this mission, but there were a lot of technical things to overcome. So we got to work. We started bringing on more people, lots more engineers. I jumped right in, started drawing schematics. Like, this is one of hundreds and hundreds of pages of schematics for the electronics in this thing. Started building hardware. This is a picture of our very first, what we call the beacon. This is what communicates with the airplanes while they're flying. And then we built our first aircraft, which we bought at Walmart. And we basically glued some electronics on it. And it was really, okay, we know we have a lot of lessons to learn, so let's start flying as soon as we can. One thing about working with zipline is I've learned that it's okay to plan to not be successful right off the bat, and that is why they've been successful, is because they planned for that. They planned for a couple of years of building different aircraft and iterating. So after this, we built our first aircraft that was fully custom. We named them after birds. This one was called the Goose. I don't know why they don't choose more exotic bird names, but this was Goose here. Our first aircraft that we delivered with in our testing grounds in California. And then this was Cardinal. This was our first commercial aircraft. So this was our first aircraft that we delivered to Rwanda in 2017. And so we've been operating there for, it was in fall of 2016, so we've been operating there for exactly 2 years now. One thing I'm skeptical about is we're a startup, how are we going to find somebody to hire us to serve their medical needs? This is life-saving supplies. And what we found was the government of Rwanda is very forward-thinking, very excited to embrace the latest technology, and they had a pretty major problem that needed to be solved. They, before zipline started operating in Rwanda, they had the highest number of postpartum deaths due to hemorrhaging in the world. So it was a great place to get started. We had a lot of technology to develop, though. Everything in this aircraft is designed basically from scratch by the engineers. We found that we really couldn't use off-the-shelf technology to achieve this mission. So what I'm going to talk about here for a little bit is, you can go home and you can Google zipline and you can see their videos and read there's thousands of publications out there you can read about what they've done. But I want to kind of give you an insider's view into what we've had to do to make these airplanes successful. So you'll notice in the picture there's no landing gear on the plane. It does not take off or land on a runway. So what we do is we launch these things using an extremely high-powered launcher. They show you a video of one is launching. So in my opinion, just developing that launcher alone should have been the entire mission of a company. We started with, well, we started by launching these planes by hand when they were smaller. We'd get 2 or 3 people running as fast as they can. And then as the aircraft got heavier and needed to go faster, we launched it from the top of a car, which was a little scary also. So then we built a pneumatic launcher. This thing had an air tank like the size of the stage and sounded like a cannon going off when it launched the airplane. And it worked really well, but we were just terrified of the thing, so we had to figure something else out. So our first launchers in Rwanda we ended up using medical grade elastic bands and a winch that you'd have like on the front of a Jeep would pull the carriage back, and then we'd let go of it. And that's actually what we deployed in Rwanda when we originally went there. But the problem is these elastic bands had to be changed out like every 100 launches. And before we knew it, that was like once a day, and it was really becoming a problem. So then we iterated to this all-electric launcher, which is very exciting for an engineer. It uses a 700-volt power supply that can provide upwards of 1,000 amps of power during the launch. So you can imagine several hundred horsepower pushing that plane, because within 20 feet, it's going over 60 miles per hour. So then we had to figure out, how do these airplanes land? Again, there's no landing gear. So we started by pinning a hook on the airplane, a couple of fishing poles, lined between the fishing poles, and we called it our fishing pole recovery system. And we'd fly the airplane real close to it, and when we were lucky enough not to just run into the line, the hook would catch the line, and we'd have a graceful landing. We then found that we really needed to try to catch the plane. So then we came up with this system, which a boom would drop from the plane, and an arresting cable catches that boom and drops the plane down onto an inflated mat. This was also what we originally deployed in Rwanda, and it worked pretty well, but the plane came down one wing, but a little lopsided. We were breaking wings on occasion, so that was the problem. So we had to iterate the recovery system also, so I'll talk about that here in a moment. But this is our team in Rwanda. You'll notice that we didn't just send a bunch of our employees out to Rwanda. We hired a bunch of top-notch people in Rwanda who were just excited, super excited to learn, and it was unbelievable how fast they were able to completely operate the system, and we no longer even needed a presence in Rwanda. And then we just have an amazing staff there operating these systems. So here they're celebrating the retirement of this airplane. We knew it was going to be a prototype when we built it. We knew we'd iterate again. And what we came up with was our current generation of airplane. This is a computer model of it here. Basically, it got big enough that one person can't handle it. So we came up with a modular design where the battery comes out, the wings come off, and you can carry it to and from the launcher in multiple pieces. It's faster than our old aircraft. It cruises at 100 kilometers per hour. It has a range of over 160 kilometers, which is 200 times larger than the delivery area if you're going with a quadcopter. It has a capacity of 1.75 kilograms, much higher reliability than the previous aircraft, easier maintenance. We use what's called LRUs, line replaceable units. So if something isn't working right, you can say there's a problem with the wing, you pop off the wing, pop a new one on. If there's a problem with the tail, you pop it off, pop a new one on. You're not trying to replace individual components in the field. And then one of the other things that you notice on the other aircraft, the propellers are mounted on the wings. This time they're mounted on a pylon above the wings. One of the complaints we got was the aircraft are noisy. So our engineers figured out that, hey, with the propellers behind the wings, they're operating in very turbulent air. So by nature, the turbulent air is very noisy as the propellers cut through it. So by putting them on the pylon, pylon above the aircraft, if this thing flies above your head at its cruise altitude, you can't even hear it. You don't even notice that it's there. As part of the reliability, high reliability that we're striving for, there's 2 propulsion motors. So the one in the front operates under normal circumstances, but if it fails, the one on the back spins up. So the props open up if it spins up. And these motors, like I said, we had to build everything from scratch. We even custom designed the motors. They're 1 inch in diameter, they're 1 inch long, and they're over 1.5 horsepower capability each. So then as the team developed the new system, at this point we've gone from 4 engineers building the aircraft to over 40 engineers designing this thing. So I got right to work with electronics. Here's one of my designs. This is the circuit board inside of the wings. So this controls all the control surfaces inside the wing. And basically when they drop the wing onto the aircraft, it connects right up. The circuit board has to be completely waterproof, weatherproof. It gets coated and encapsulated. And then everything is dual redundant. So you see two of the exact same thing. If one fails, the other kicks in. All our flight control surfaces are redundant, so if one flight control surface fails, the plane can still finish its mission. Here's another example of one of the custom designs we had to do. This is what I call our motion controller. It controls the system that captures the airplanes as well as the system that launches the airplanes. And of course, all of this stuff has to be tested, debugged. Here's a picture from my lab in Denver, where I'm doing analysis on our motion controller. And we've got to manufacture everything. So most of the manufacturing occurs in California, but I work remotely here in Colorado, and I really strive to keep as much of the manufacturing that I'm in charge of here in Colorado. So these are what are called our beacons. These communicate with the airplanes. They're 100% manufactured here in Colorado, assembled and tested at my place. One of the other things I manufacture is our wingtip lights, which have to be visible from 3 miles away. So here's one of my guys testing these wingtip lights. He has to wear welding goggles while testing them because they are so powerful. So then, of course, we had to update our launcher to launch a much larger aircraft. It launches it within the same envelope using an extremely high-power electric motor. I can't really explain how exciting it is to see these things in person. It's sitting right there in front of you, and in a blink it's gone. And within about another 15 seconds, you can't even see it in the sky anymore. So one of the things we also iterated on was how we catch these airplanes. So on the bottom right, you'll see the tail hook from our original aircraft that we worked on in Rwanda. It is a large tail boom. The idea came from how do fighters just land on aircraft carriers. They drop a big tail boom, and there's 5 cables on the carrier, and they hopefully catch one of those 5 cables. So we went with the same route with the boom with the hook on it. We only have 1 cable, but the plane goes full throttle right as it's coming near the cable, so it can do a go around if it has to. But we wanted to get rid of this tail boom. It caused us problems. They broke sometimes. Sometimes they weren't deployed. They looked funny. So if we look really closely at the tail of this airplane, you can see the new hook that's on it instead of that tail boom. Here's zooming in on that. So the hook is now 1 centimeter in size. So we use a cable that's 1/2 centimeter in diameter to catch a 1 centimeter hook on an airplane that's going 100 kilometers per hour. And the cable is going over 300 kilometers per hour when it moves to catch the hook of that airplane. And it's so precise, we've never damaged an aircraft with this cable. And it's very rare that the aircraft is even missed. So here's what we call it's our new recovery system. And it also does not put the aircraft down on a mat because since, as I mentioned, that was damaging the aircraft, we decided we've got to catch it in the air and just hold it in the air until it's fully decelerated. So the cable pays out as you, let's see here. Here's a picture. The cable pays out as the aircraft is caught, and it's decelerated fast enough that as it swings down, it will not hit the ground. So here's a video of an aircraft coming in for recovery. It's a slow motion video, so you can kind of see what's going on. So you saw that the holes. Yeah. That was our very first recovery of that aircraft. You can tell we were excited. Then the next generation after that one It took us 28 attempts to catch it. Thank goodness it had a full battery when we started those attempts, but we did catch it. So we do a lot of testing. That has been one of the keys to reliable operation is testing. So much testing, we budgeted losing more than 2 aircraft a week due to testing. So we're just cranking these things out like crazy so we can really figure out what their envelope of operation is. Here you can see where we drop packages. We've dropped 50 packages here, and this was tuning the algorithms because once this was done, we can now drop a package within the space of 2 parking spots. So here's a video of what it looks like to drop a package. So the plane drops down, slows to almost a stall, opens its belly to drop the package parachutes down, and then you could hear it going full power to pull up and out before it stalled. In Rwanda, there's many clinics where we operate in urban areas where the plane almost nosedives down to where the clinic is, almost stalls, drops the package, and then climbs almost vertically out of the area where it dropped the package in order to avoid nearby buildings. Other testings we've done, you can see we really abuse these things to figure out what is the weakest, what are the weakest structures in these airplanes? What do we need to harden so that they have the lifetimes expected? We're designing these airplanes for over 1,000 flights between maintenance intervals. We've also equipped each airplane with a parachute, so if something horrible fails, if we have a critical failure within the airplane, it can parachute to the ground instead of crashing to the ground. We had to figure out what's the best way to land, where do we mount the parachute, how do we best land the airplane to minimize damage. So here you can actually see a picture. This was taken from a camera on the wing of the airplane as we were doing a test parachute drop. Once we got through all this testing, could provide to the aviation authorities, hey, this system is reliable, and could show them hundreds of incident-free flights, then we got approval to start flying multiple planes at once. So here you can see in the sky, there's 2 airplanes. We had just caught one, and right now, almost any time of the day, we have at least 10 to 12 airplanes in the air in California at our test facility. We do hundreds of test flights a day. And through this, we're able to fly in all sorts of adverse conditions. So this is a picture from Rwanda where they launched an airplane at night into a monsoon rainstorm. And everything on this airplane had to be designed to be waterproof to fly through these kinds of conditions. We also, one thing that was a huge deal for us is we achieved approval to fly at nighttime, which, as far as we know, we're the only commercial company with approval to fly autonomously at nighttime. So this is a video of an airplane taking off at night. It's kind of cool to see them take off. And then you'll see another one here from a different angle. I should mention, so these airplanes, their flight computers on board, there is no pilot anywhere. They completely 100% fly themselves. So we load the mission on them, and then they go and do the mission. That's how we're able to fly a whole bunch of planes at once with very little ground support. The operators, they use iPads or iPhones to see what's going on with the airplanes. This is a typical view of what an operator would see. The aviation authority, the control tower, will also have this view. So in Rwanda, it's the Rwandan Civil Aviation Authority will have this view. So they can see, like right now, there's 6 planes in the air. 3 are outbound to deliver supplies, while 3 are inbound. You can see the map with where the airplanes are at. The Rwandan Aviation Authority has the ability to command the airplanes to any flight level they want. We have all sorts of predefined corridors, so they can command any plane to move to any corridor, or worst case, they can command a plane to instantly return home or even to terminate its flight at any time. So they have all the control in their hands. They need to make sure that we operate safely. These airplanes, like I mentioned, they're very modular. So these are the bodies lined up. So an operator will grab the body, put it on a launcher, and then go and grab a wing. So here's a rack of wings. Put that on top of the body of the aircraft, and then they'll drop a battery in. So here the batteries are charging. They'll put the battery in the aircraft, and then it's ready to go. So you only need one person, worst case, to launch one of these airplanes. We, at each base, we keep at least twice as many batteries as there are aircraft. That way the aircraft can all stay in the air all the time if they need to, and the extra batteries are charging while they're flying flights. We found how important this was within about 2 months of operating in Rwanda. We got a call for emergency blood, and we sent an aircraft with blood, and before it even got there, they said we need more. So we launched another one, and they said we need more, so we launched another one. And before we knew it, we had all of our aircraft in the air carrying blood to this one single clinic. They had us operating in that, and it was a clinic a long ways away. It was like 100 kilometers away, so it took about an hour and a half, since that was our first generation aircraft, to get there and get back. So we just got them all in the air cycling, going, wow, they're sure asking for a lot of blood. And we found out later that it was all for one patient. She had just had a baby, and by the time it was done, they transfused more blood into her. There was three times what she would have normally had in her body. And no clinic in Rwanda would have had that much of the type of blood that she needed. But she was able to survive because of hours and hours of just constant deliveries over the course of a few days. So I'll show you a video here that kind of outlines our operations, kind of from the time that we get a call to the time that the delivery is made. Maybe I won't show you the video. Okay, anyways. So we have what we call our medical operators. They're generally pharmacists who will handle the medications and the blood. So in Rwanda, we keep all of the blood at our facility for the country, or I should say our 2 facilities. So when they get a call, they check it out, make sure that it's the right type, make sure that it's not expired or anything, weigh it. I sped this video up a little bit because I think he knew he was being filmed, so he was going kind of slow, and just sped it up a little bit more. But they check out, they package it in a box that's already been equipped with the parachute. You won't believe it, just designing the parachute for this box took a couple of engineers, like a half a year. We dropped over 1,000 different test boxes before we were happy with the parachute on this thing. But we have never lost a single unit of blood to the impact from the drop, so it was a good investment. So then the medical operator hands it over to a flight operator who takes it, puts it inside the airplane. Kind of missed that part. So he just stuck it in the belly of the airplane, and then he scans to make sure that he has the right airplane, the right package, and then he'll go and take it out and put it on the launcher to prepare it for launch. At this point, the airplane has no idea where it's going yet. You'll notice that the launcher is under a cover because the rain there gets so crazy that we wanted to provide them cover so they can operate in all sorts of conditions. So once you push on the launcher, they'll then bring a wing over, and the wing just drops right onto it. And then once they've got the wing in place, then they'll bring the battery. The battery is the majority of the weight of the aircraft. And it also contains all the flight information. So while the battery's charging, our system uploads it with all our latest surveys, all the latest software for the plane, and then with the mission plan for where the plane is going to go, where it's going to deliver, and also the paths of other planes that are in the air. But the planes will communicate with each other during flights also to coordinate to not have collisions with each other. So then they do a pre-flight check before launching, and then they calibrate the flight control surfaces. This is a technology that most of our pilots actually sit behind, is how they calibrate those flight control surfaces. So they get permission from the Rwandan Civil Aviation Authority to launch. That's what you just heard. I'll show the launch from a few angles. So when the airplane's running before launch, it's testing all its systems those last few seconds right before launch. We used to actually launch the plane and fire up the propellers halfway up the ramp. And it took one time of them not coming on for us to realize let's fire them out before we launch the airplane. So once the plane's launched, it flies its mission. Here you'll see it drop its package here. You notice this is actually our first generation plane. You'll see the tail boom. And in this case, the package drops down right in front of the clinic where it was ordered from. So then the plane comes home and we catch it, and it's ready for its next mission. I should also mention, so when the clinic needs blood, they actually send us a message through WhatsApp. It's kind of like the new kids' version of texting. So they'll send us a message through WhatsApp, and that's how we find out. We have a prescription system through that. So then the plane gets caught, and once it's caught, the system will drop it down so that an operator can come and grab it. Once it stops swinging here, you'll see a guy come out and he'll grab the plane. And again, he can disassemble it right there on the recovery system so that one person can put the airplane away or take it straight to the launcher if necessary for the next flight. So you'll see that they detach the wing. Actually, they remove the battery first and then detach the wing. And then they'll come and grab the airplane off of the recovery line. And they're all ready to go again. So one thing that Zipline does is kind of cool is at least once a week they like team morale. I think in any company team morale is important, and they found a really good way to build team morale. And what that is they find patients and they go and interview those patients, and they'll play those interviews during our team meetings. So this is one of the ones that I was definitely touched by when I saw it.
Iyo nabona ayo maraso bari gushoramo igihe baba bava amaraso n'igihe yatugereyeho ntabwo bitangirimo ndabona amaraso nawe ntayitokera ko ariyo yagize umuntu.
We can avoid experiments, we can avoid stockouts because the supply chain has improved. Blood is life, it is saving life for Rwandans.
Zipline must cover all weight. It will be everything.
I wish all countries partnering with Zipline to deliver to the needy population. We have to make a great effort to make sure that we avoid every single day. It's the greatest investment we have, our people. And every single opportunity that can add value to what we are doing, we take it.
Some interesting stats. A lot of the blood in Rwanda was going bad because deliveries would take 4, sometimes 6 hours, and sometimes by the time they got there, they were no longer needed, unfortunately, and other times the blood would expire along the way because it has to be kept at a very specific temperature. And also stocking the blood in clinics, it would tend to expire before they could use it. So as of now, the spoilage and loss of blood in Rwanda has been reduced by over 95%. They have less than 1% of their blood spoilage. We've made over 7,000 deliveries in Rwanda, and 1/3 of which were emergency deliveries, and we've delivered a total of over 13,000 units of blood to date. We're in the process of expanding a little bit. So we've been operating from one hub in Rwanda. That's the one right in the middle. Wherever you see the blood droplet is a hospital, and where you see the little dots, those are clinics. So those are all of our customers. And we've designed a base now that's, you see in the upper right, so we've got a second base going into Rwanda that will be opening within days of now. They're doing their test flights right now, and within days they'll be opening that base. Just in September alone, 457 deliveries were made with 814 units of blood. And then some other interesting areas that we're expanding to is in Ghana. We will be opening 40 sites in Ghana over the next 2 years. So many of those sites are in construction right now. And then our first site in the United States has just recently been approved. We will be opening a distribution center in North Carolina to deliver to rural parts of North Carolina. This here is the second base that's opening in Rwanda, just to kind of give you an idea of what the base looks like. And also because it's a really cool video, because somebody actually flew a drone through this base to catch the video. So you can see outside the battery charger set up. And since this video was taken, they've now fully equipped this base with over a dozen aircraft and sets of wings. You can see outdoors where the launchers and where the recovery system is. In Ghana, they're planning a 2-week deployment to each base. So from the time they start construction to the time they're ready to start test flights, 2 weeks. And then lastly, I thought this was kind of a cool picture. If you recognize, this is the Air and Space, the Smithsonian Museum of Air and Space in Washington, D.C. And this is right at the entry, and one of our airplanes is now on exhibit there. All of this is possible because of a handful of guys that brainstorm wanting to do this, and having a passion for this, and having the engineering skill necessary to do this. And think of all the amazing things that our next generation will be able to do with technology, with that interest and passion for science, engineering, math. And I can tell you, one of the reasons I'm here is because of John McConnell, the mentoring that he provided. And I can only imagine how many young lives have been touched by being able to come through the McConnell Science Museum over all of the last 20 years now. And I want to thank all of you for your contributions, your generosity to making this happen, because I can tell you there's going to be so many kids in the next generation whose career paths were forged because of being able to come to the McConnell Science Museum. I know 3rd grade was a pivotal point in my life. Had my 3rd grade teacher not noticed I needed that help and reached out, and if John didn't stand up to the plate, I know I would have been a long ways behind where I am right now. So thank you for your support for science and math. It's great.